Hi ladies and gentlemen, I hope everyone is doing well today. Today we are taking a look at using moles with formulas part 2. So right up top we're starting with some information about calculating empirical formulas. So what I've highlighted in pink is when you know the percent composition, you can calculate the empirical formula of the compound. There are 3 steps that we use to solve these problems. I will talk about each of these 3 steps and explain how they apply to example 1. Example 1, we're looking at a certain compound which is 30.4% nitrogen and 69.6% oxygen. What is the empirical formula? So the first step is to take the percentage and to divide it by the mass that's found on the periodic table. In these examples, they did round. For our purposes, we are going to say do not round. So on our periodic tables, most of the masses are in 3 decimal places. I expect you to use all of them. So that's what they did here. You find the mass of 14 and 16. So the next step is step 2. This is where we find the ratio of nitrogen to oxygen. So we do that by looking at the answers from example 1. We take whatever one is smaller and we divide both answers by that. So then if you look, we would see 2.17 is smaller than 4.35. So you need to do first 2.17 divided by 2.17 and then 4.35 divided by 2.17. That is what we see happen right here. We see the answers, anything divided by itself is 1. And then remember, you don't have to know how to do this in your head. You can use a calculator. You'll always have access to a calculator. So we just type it in, we get 2. Next, step 3 is to write the formula. The answers from step 2, 1 and 2, become the subscripts. The 1 is associated with nitrogen, the 2 is associated with oxygen. That's why we get NO2. So that case was an easier one. Sometimes when you solve for the subscripts, you will get a decimal. So this one is 1.0, this one is 2.5. What you need to ask yourself when you get a decimal is what times that decimal gives me 1. So in this case down here, you do see that both subscripts had to be multiplied by 2. We picked 2 because 2.5 times 2 is 5. Anything times 1 will be a whole number. So when you are doing this, there are 3 decimals that you guys need to keep in mind. The first one are decimals that are close to 0.25, decimals that are close to 0.33, and decimals that are close to 0.50. Decimals that end in 0.25 will multiply both subscripts by 4, 0.33 both subscripts by 3, and 0.50 by 2. We multiply it by these numbers because that is what gives us a whole number. So next, question 1. Question 1, you need to find the empirical formula. You're going to find the empirical formula by using these 3 steps right here. Make sure you follow them. You will have to find the mass of N and the mass of H on the periodic table. Do not round those. So just make sure you use all of the digits. Next we have some information on molecular and empirical formula. So let me just make this a little bit higher so it fits everything. Okay. Cool. So remember, the empirical formula is just the most simplified version of the formula. It's the simplified version of the molecular formula. If you're given NO, you would not be able to tell what the subscripts are. You can, though, if you are given the molar mass. So question 2 walks us through a problem finding the molecular formula. So I wrote out the steps on the side. So what you do in A, step 1, whenever you find a molecular formula, is always find the mass of the empirical formula. Step 2 is to then divide the given molar mass by the molar mass from the periodic table. Remember, we don't round. And then lastly, step 3 is to multiply the subscripts by the value you found. So now I'll show you each of these steps through example 2. So question 2 is asking us to find the molecular formula for NO. It gives us the empirical formula and the molar mass. So step 1 is to find the molar mass of the empirical formula from the periodic table, not the one that's given to us. We need to compare those 2 values. So we do that. We use all the decimal places. Remember, we're not rounding, and then we multiply it by the subscripts. We chose 1 because the example we're looking at is NO. When nothing's written, the subscripts are 1. Once you multiply and add 30.06. Next, step 2 is to divide the molar mass that's given to you by the molar mass of the periodic table. So that's what I did. I took 60, it's the molar mass given to me, and that's what I started with. I divided by 30.006, which is the molar mass of the periodic table. That comes out to 1.9996. This value is very close to 2. When you round, with part B, you're trying to round the closest to 0.25, 0.33, 0.5, and 0.0. The 0 just means the 0.0 at the end. So that's like any whole number, 1, 2, 3, 4, 5, and so on. Step 3 is then to multiply the subscripts by the value found in step 2. So in step 2, we found that the value is 2. So that we use the value 2 down here. We multiply N 1 times 2, O 1 times 2. That would give us the molecular formula N2O2. Remember that this 2 up here tells us that 2 empirical formulas fit in the molecular. That's why just multiplying would make sense. Then lastly, what you need to try is question 3. And question 3 is a little different because you need to find the empirical formula in part A, and then part B asks you to find the molecular formula. So it is both parts of this chemquest combined. Like always, if you have any questions or need any help, please circle it and write down your question. I hope everyone has a good day.